Okay, here's our problem 47. This is 1047, and what we have is a company that has three different, they've got 10 maybe different department stores, and what they need to do is allocate the cost of purchasing. So what they decided to use was the dollar value of the merchandise that's purchased, and that's not really a bad idea. You'd think that that would be, a decent variable that could maybe have some relationship to how much purchasing costs are. But then probably if you looked into the data a little bit more, you'd find that maybe some store had certain expensive things that they bought, so there's really not any relationship. The guy went to a conference and he found out that the number of purchase orders and the number of suppliers were really actually better drivers of that cost than the number of dollars purchased. Okay, and that could happen easily in a company, really easily, because if it makes sense at the time, and then if you've been doing it for years and years, you just accept it, So we've got three regressions here. One where it's based on the number of the purchasing department costs. That's the first one. That's like purchasing dollars. And here it's the number of purchase orders. Okay, and the last one is the number of suppliers. So your goal here, what you want to be able to do is to look at these results and then to be able to interpret them. Okay? So the first thing that they ask for you to do is to compare and evaluate the regressions. And that's what we have here. So let's take a look at the first one, for purchasing dollars. The presentation at the seminar didn't find any support for this as a variable, and the purchasing personnel didn't believe it was a good driver either. Okay? For goodness of fit, we would look at the R squared on here, and the R squared here is 0.08, okay, which is really low. Okay, so that would indicate a poor fit. And the other thing that I like to do is look at the chart itself, and the chart's crazy. It looks like a constellation or maybe like a dog, okay, but it really doesn't look like a relationship. So, and then when we looked at the t statistic, on the t value on the independent variable, the number of dollars of purchases, it's 0.83, okay, and that is an insignificant t-score, okay. In terms of the specification, the linearity is questionable, especially when you look at this, but they don't have enough evidence that they can really say it is not linear, all right. The constant variance of the residuals is also questionable. The independence of the residuals is the Durbin-Watson statistic of 2.41 is not low enough to reject the assumption of independence. So I think that you want this score to be around 2.0. And, I used to do work like this, and I never used Durbin-Watson, but apparently the textbook does. Okay, there's a lot of different things out there that you can use. And then finally, for the normality of the residuals, it's the last thing we look at, that the database is too small to really draw any conclusions. That's the problem with that, okay? And you really need data. You need data to do it. And I put the data in here a little bit, and here we have the number of purchase order dollars increasing in this. Oh no, these are purchasing department costs, and that's the number of purchase orders. Okay. Oh no, sorry. Yeah. I did purchase orders and suppliers. Here's the merchandise purchased alone right here. Like I said, it looks like a or actually it does kind of look like a dog, but to have one number down here at 120,000 is the same amount as it was when it was like 30,000. So that doesn't make any sense. The next one, for the number of purchase orders, it is plausible. The higher the number of purchase orders, the more tasks were undertaken. That makes sense. It's just a reasonable thing. An R-square of 0.43 is a reasonably good fit. And you might think that it's really crappy, it should be something in the 90s, and in reality you don't get numbers that high, generally. Okay, I've seen a lot of accounting studies even where the number is more like 0.35, and that's considered really good. Okay, so 0.43 is not too bad. I mean, you could probably throw more variables in there and get a better R-square, be better able to account for what the change is. And that's what we do in the next problem, okay? The t value is 2.46. That is significant. They don't tell us at what level though, right? Is our t value 2.46? And both linearity and the constant variance of the residuals is reasonable. Durbin-Watson is 1.97. You can see how it's going down here. Assumption of independence is not rejected. And again, the database is too small to really draw any conclusions here. The minimum size that you need for regression is 10 instances, and that's even really small. 30,000 is better. It would be a better number. And when you look at the graph of this is the number of purchase orders. You got sort of a nice line here, okay? That doesn't look like a dog. This is pretty good. And this is the number of purchase orders, or the costs going up here, and there are your number of purchase orders increasing. So that makes sense. You can see a relationship there. And the very last one is based on the number of suppliers. Here's the data. So the number of suppliers kind of varies a little bit here, but as it generally goes up, as the number of suppliers generally go up, the costs go up. Okay, so at least everything's going in the expected direction. For economic plausibility, it is plausible. Okay, it does make sense. The R square is 0.39. Where'd it go? Here, 0.39, and that indicates a reasonably good fit. Okay, but you can see that the number of purchase orders was better, and then the t value on the number of suppliers is 2.25, that is also significant. The linearity and constant variance of residuals is also reasonable. And then finally, the independence of the residuals is the Durbin-Watson statistic again, and it's right around 2.0. So, you can't really reject the assumption of independence. And what we're concerned about here with the residuals is that, if they're really related to each other, then we missed a variable in our specification. Okay, so you want the residuals to look all crazy and not related. Even if it's important. Normality of the residuals, again, it's too small to make any inferences. Okay. So I hope that helped. But you don't have to stand on your head with this, but this is about what we need. Okay.